For a sample, we find statistics such as x bar, s squared, and s, mean, variance, and standard deviation. For a population, we talk about parameters, mu, sigma squared, and sigma. You're going to be asked to come up with unbiased estimates of the population based on data collected. So x bar is always going to be an unbiased estimate of mu. So we can make the inference about our population just from the sample mean. For the variance, we have to do a small calculation to get the unbiased estimate of the population variance. And we're going to take n divided by n minus 1 and multiply by the sample variance. And that will give us the unbiased estimate. There is no unbiased estimate for standard deviation. That's one thing to keep in mind. This is the formula for standard deviation for group data, such as frequency tables. This is f times x minus x bar squared. So here we have some scores. We've got a score of 1, 2, 3, 4, 5, and it's recording the frequency that each of these happen at. To find the mean, remember the formula is that. So what we'll need to do, and probably the easiest thing to keep yourself organized with all these numbers, is to add a new row to this table, f times x. So 1, 4, 12, 8, and 5. And now we can plug in to this formula the sum of the f times x's. That's going to be 30. The sum of the frequencies is 10. So x bar, our mean, is 3. To find the standard deviation, we're going to need to take x minus x bar as one of our columns. So we're going to be doing 1 minus 3, which is negative 2, 2 minus 3, which is negative 1, 3 minus 3, which is 0, 4 minus 3 is 1, and 5 minus 3 is 2. And then we need to take each of those values and square them. So I'll have 4, 1, 0, 1, 4, and then the formula says to take the frequency times each of these. So we'll have 4, 2, 0, 2, 4. 4 times 1, 1 times 2, 0 times 4, 1 times 2, and 4 times 1. So here's that formula for standard deviation. We're going to add up this last row. That becomes the numerator. So we have 12 over 10. Our standard deviation is approximately 1.1. This is called a normal distribution or bell curve, and the middle of this bell curve, this symmetric bell curve, is the mean, and then we segment it off in terms of standard deviations. So in reference to the previous example that we looked at, we could think of mu as being 3, so that's the mean, and this applies to both statistics and parameters. So 3, and then this would be 4.1, 1 standard deviation above. This would be 5.2, that's 2 standard deviations. 6.3, 3 standard deviations, and we can go the other direction. This would be 1.9, 0.8, and so on. There's a nice truth to this bell curve in that 68% of all the data will be between 1 standard deviation away from the mean. 95.5% of our data will be within 2 standard deviations, and 99.7% of our data will be within 2 standard deviations. And that's usually where we stop looking, because essentially beyond 3 standard deviations, we're talking about very, very, very little of our data. And while there's still some out there, the vast majority of it is within 3 standard deviations. And one thing to note is that 1 standard deviation either side of the mean, this normal distribution, is where it changes concavity. And we can use this to answer some questions. So I have a sample of 200 cans that was taken from a warehouse. The mean weight was 486, standard deviation being 6.2. So I'm going to model this with a bell curve, putting 468 or 486 in the middle. 1 standard deviation would be 492.2. 2 standard deviations would be 498.4. And then going the other direction, we would have 479 as 1 standard deviation below, and you could keep filling in 3 standard deviations above, 2 below, 3 below. But what I'm wondering is what percent of the data would be between 479.8 grams and 492.2 grams. In other words, what percentage of the data is in between here? Well, that's 1 standard deviation away from the mean. So we could just say that this is 68%. What percent of the data would be less than 504.6? Well, that's going to be the 3rd standard deviation out here. We know that from 3 below to 3 above, we know that that is 97.7%. 99.7%. That leaves 3%, 0.3% to be split between the tails out here. This would be 0.15% in each tail of this bell curve. So we want everything from 504 and less. So that would be 99.85% total. Using your calculator, To put data in, you're going to hit your stat key and then go into edit, and you're going to put in your list of data, usually into list 1. And I just made up some data here. And then I'm going to go back to the stat menu. I'm going to go over to calc, and I'm going to select one variable stats, and I'm going to tell the calculator right now, you need to select the data from list 1. And I'm going to push enter. X bar, the mean, sigma x is the standard deviation, and if I scroll down, I can see the 5-number summary. I can also create a box plot for this. I hit second and then y equals. I go into plot 1, I turn it on, and I'm going to go down to change the type from scatter plot to one of these box plots. And I want my X list to be L1. If I had my data in L2, I could switch that. Now I'm going to go to zoom and go to zoom stat, and that's going to automatically fix my window to fit the data that I have. So there's my box plot. And in that stat plot you can also make histograms for frequency tables. And to put a frequency table in here, in list 1, what we're going to do is we're going to put in the midpoints for each class, or the data value that's being tracked there. And then into list 2, we're going to put the frequencies. And then I can go back to my stat menu, over to calc. Again, one variable stats, but this time I need to tell the calculator to use list 1 and list 2, that list 2 has frequencies in it, so I'm going to put comma list 2. Then I push enter, and here's all that data again. The mean, the standard deviation, you can find the median from this 5-number summary. Although you have the ability to use your calculator to do these calculations for mean, standard deviation, you do need to be familiar with how to use the formulas that show up in your formula pack. So you should practice these problems both ways, I would say. Do the work by hand, and then simplify, and then check your work using your calculators.